Hello everyone, my name is Wilson and I'm a senior pre-sales specialist for IoT and AR with PTC. In a global enterprise, monitoring assets worldwide is a massive undertaking. The complex nature of asset management creates unique challenges from the factory floor to the entire product lifecycle. For a company providing wastewater treatment, getting control of their asset information is a critical component in transforming legacy systems and practices into a leaner, modern, and more efficient enterprise. Today, I'm going to introduce you to one of the fictitious customers, Liquidom. Liquidom is a global engineering business focuses on providing clients with industrial products that helps multiple sectors improve their daily processes, from mine ventilations and wastewater treatment to heating and cooling. Their core focus is on providing quality solutions for air and gas handling, and with over centuries of experience in doing so, it is no wonder that they are renowned for such projects across multiple sectors. Liquidom decided to work with PDC because they wanted to use Internet of Things and augmented reality to enhance their product functionalities and to provide more values to their customers and stakeholders. By connecting their equipment in the field to ThinkWorks platform, they were able to monitor hundreds of units at customer sites worldwide with capabilities to gather and analyze critical equipment data, to optimize equipment performance, and to provide their customers with insights. These transform their customer relationships from transactional to collaborative. In this demo, I'm going to show you how a Liquidom remote technician can monitor the equipment to gain insight into its performance in the field, to troubleshoot and resolve the issue with the equipment. And then we are going to move to a field to see how an operation manager using IoT data to increase equipment uptime and to ensure operations are running smoothly. And finally, we will see how a service technician using augmented reality to fix a faulty equipment. The equipment we are seeing now is a diaphragm compressor. This compressor could be used to change low pressure gas or liquid to high pressure by means of a flexible membrane. It would typically be used in situations where complete hermetic separation is required. For example, in the handling of toxic, flammable, or explosive gases. In this case, this compressor is used to inject oxygen into the sedimentation tank of a wastewater treatment plant to help accelerate the microbial sanitation activities. I'm going to start our demonstration by taking on the role of a remote service technician at Liquidom. Here, we can see how a remote service technician at Liquidom are able to use a role-based dashboard to monitor the fleet of assets deployed at customer sites worldwide. By selecting a particular equipment, say for example, diaphragm compressor 01, we are able to view general information about the assets, like model number, model name, and serial number. We are also able to view status and performance data of the equipment, for example, the current flow rate, and the power consumptions, and speed and pressure. And we are also able to view the equipment documentations and also the historical data such as flow rate and speeds. And we are also able to compare real-time data and performance data across different equipment. By navigating to the Dashboard tab, it provides me with more detailed information about the status and performance over time of all equipment that are deployed at customer sites. In this case, I can see that the operation status for diaphragm compressors 1 is currently good, but our prediction model is showing abnormal. In the background, we are running different modules from ThinkWorks Analytics to analyze condition data from our equipment in the field with machine learning technologies. Based on the historical data from similar compressor, we created prediction models for the most critical problem. And as you can see on the left-hand side, we see both the current warning status of the machine and the abnormal status that our model is predicting. Let's navigate to the Deer Island plant site. It is where the diaphragm compressor 01 is located at. In the alert area, we can see that there is an active alert predicting that there will be a pressure leak for the diaphragm. In the live data area, I can see data coming off from the field in real time. I can easily review historical data for pressure, for flow, for speed, and power on this unit to better help me understand the state leading up to this potential failure. Looking at the low pressure and low flow rate here, I have determined that we have a ruptured diaphragm on this compressor. I'm able to remotely access to this compressor to fix some of the problems, but this requires a service technicians to replace the critical part. I'm going to create a service ticket to dispatch a technicians to fix the problem. So over here, I can fill in the descriptions for my service tickets, which is diaphragm ruptured, and the resolution is to basically dispatch the service technicians to fix it. And the status is still pending. Later, we will see how a service technician uses augmented reality to fix the problem. But first, let's take a look at this compressor from the perspective of the plant manager at a wastewater treatment plant. Here, I can see how the same type of information might be provided to a plant manager. I want to know the status not only for the assets, but also of the wastewater treatment process itself. Over here, I have several of these diaphragm compressors, but I also do have blowers and pumps from a collection of different vendors. I want to make sure that they are all operating well independently and as a systems. And on the right-hand side, I can easily see all my individual assets with their current states and current alert states. On the left, I can see an operational view of the plant as a whole, from the intake of raw wastewater via the influence pipes, to the sedimentation process, to the aeration process in the middle, through the three clarification tanks at the top, and eventually all the way through the discharge of treated water. Within each of these systems, mechanic, chemical, or biological processes are occurring to remove pollutants from wastewater so that it can be directly reused or returned to the water cycle with minimum impact on our global environment. Each of these processes have information that we can track to understand if the process is running smoothly or trending in the negative directions. Things like water pH, water temperature, dissolved oxygen levels, and microbial levels, and etc. We can even include data from external systems that may impact our operation. Notice in the upper left of this dashboard, we have a nice sunny day and only one of our three clarification tanks is online. Let's trigger a weather change. When raining is in the forecast, we will get an alert that prompts us to determine whether we need to bring more of these tanks online to handle the additional load. When an alarm is triggered for one of the compressors, the green outline of these assets, as well as for any associated plant component, changes to yellow, indicating that there is a potential problem with the operation or quality within that systems. We see that diaphragm compressor 1 status has changed to yellow, and the location of diaphragm compressor 1 near the pump house has a yellow box. I can then select the yellow box on diaphragm compressor 1 to view the alert details. Looking at the pressure and power of the compressor, we see that there's a sudden surge of the power consumption and a drastic pressure drops. That implies that we have a rupture in the diaphragm. Next, let's take a look at the process view so that we can see the impact of these alerts on the whole systems. From the process view, we see that both diaphragm compressor 1 and the sedimentation tank needs our attention. We have already seen that there is a low pressure on a compressor. Let's take a look at what's going on with the sedimentation tank. By selecting the sedimentation tank, we can see that the dissolved oxygen level is decreasing. Having this compressor operating below expectation is impacting the flow of oxygen into this tank. This will impact the efficacy of the biological components, slow the sanitation processes, and ultimately impact our ability to achieve the KPIs at our plant. We can now look at the other two compressors feeding these sedimentation tanks to ensure that they are operating well and can sustain the load until we are able to fix the first compressor. Let's switch gear a little bit to see how a remote service technician can fix the ruptured diaphragm using augmented reality. I'm now playing the role of the service technician dispatched to fix the issue. The mixed reality experience provides me the access to specific experience use cases, namely training, safety, operation, and service. Let's start review the training informations. I may have had this training months ago, but now with the mixed reality, I can bring it with me and apply it to the asset as I need to work on it. Here, we can learn about 5 key areas of the compressor. The first being crosshead piston, which is the piston pumping the oil. Then, we have oil pressure limiter, which is to ensure oil pressure does not exceed the limits, followed by a crankshaft, which is a mechanical system that circulates the pistons, bringing in and out the oil to compress the diaphragm. And then we have the diaphragm set, which is to produce compression to increase gas pressure. And lastly, we had a head integrity detection, which is to monitor any gas leaks in the head unit. I can even explode the compressor components to expose all its subcomponents. Selecting on key components identifies the part name and part ID. Part identification offers tremendous value to customers and service technicians who needs to order replacement parts. Ensuring you have the correct part and part number can reduce ordering, shipping incorrect parts, delaying fixes, and extending downtime. Now, let's go back to the main menu and look at the safety use cases. Safety is a top priority for all manufacturing and process plants. With mixed reality, we can expand the content of information to include what surrounds the compressor, where many of the safety concerns are taking place. In this case, we are highlighting the electrical warnings for the motor running the compressor, the high pressure warnings for the pipes transporting the gas, and the temperature warnings. This type of mixed reality experience ensures that safety and compliance measures are met to reduce risk and worker issues. Next, let's look at how the compressor operates. With mixed reality, I can view how the internal components of the compressor works, and I see that there's an active alert indicating a diaphragm rupture. Let's see how we can fix this using mixed reality. With mixed reality, I will be visibly guided through the steps. Let's start with step 1. We can simply select on the steps. As I continue to walk through the steps, you can see that the mixed reality 3D digital instructions overlaid on the real-world equipment. This gives the technicians complete understanding of the task at hand, increases their effectiveness, productivity, and understandings, which results in improved outputs, quality, and customer responsiveness. Mixed reality addresses the manufacturing skill gaps and transforms the future of work by empowering frontline workers to increase productivity, resulting in improved operational efficiencies like uptime. Therefore, it is easy to see how mixed reality can help to reduce costs and complexity associated with training, safety, operation, and service. By using the 3D CAD geometries, Liquidom is able to easily implement experiences such as the ones that I've shown you today. This is just one of the examples how mixed reality can support service technicians and operators in the field, and there are many more use cases mixed reality is able to support.